You can. I'm going to glue mine in just because that's the way I like to do my things. I like to glue them in first. But if you want to write on it first, that's fine. So we're going to end up gluing it in sideways.
And like Ms. Brown said, we're actually going to do some practice with this. So if you're able to do like Martine, and have it on a page where you have both pages available, that might be helpful because then you can do your practice right next to it. So even if you have to skip a page, that might be useful to you when we start doing our examples.
If that's going to drive you insane, it's nothing to stress you out about. You do not need to worry too much about that, but and it doesn't matter which way you put this paper. I'm just putting it so it's facing in. My head tilts easier that way. I don't know. IDK. So if you want to glue that in, you can glue that in, or you can wait until we write on it. And then we are going to use quite a few colored pencils while we do this. And when I say quite a few, we're going to use at least 3 colors, maybe 4. So let's use yellow, pink, green, and brown. Those are the 4 I'm going to use. If you'd like to use other colors, that's fine. We're just going to be marking this up a little bit and drawing some pictures. So if you want to find 4 colors, I'm going to use yellow, pink, green, and brown. If you'd like to use other colors, that's fine too. We're going to be drawing some pictures, so if you don't use colors, you should have the pictures drawn at least, because some of these proofs are pretty wordy, or not proofs, theorems are wordy. We need to have them. Hi, Yusuf, you sit up front. Right across from John Deere. Right. No? You want your back to the board? I would sit in this one, but that's my choice. So that way you can see the board, you know? The TV, the screen, whatever we call that thing. Alright. Here we go. Alright, so I'm going to flip it this way so we can actually read it. Alright, so we have 6 postulates or theorems that we're learning today. Remember, a postulate is something that we can't prove, but we know it's true. So this is an angle addition postulate. Theorems, on the other hand, this is our first time working with some theorems. Just kidding, we worked with a midpoint theorem. Theorems, on the other hand, are things that we could prove. We could write a proof to do that, and we're actually going to do that when we get to our examples, that we can write that proof. So at this point, phones should be put away. Computers can be put aside. And we are ready to go. Alright, angle addition postulate says point K is in the interior of angle ABC if and only if, and then we're going to cross this out because I didn't do that right. Letters are hard some days. So cross that out. Idris. You need a pencil? That one? Alright. So, we're going to actually write this as the measure of angle. And you're going to try and write it small so it fits across in one line. It's going to be really great. If it doesn't, that's okay. Life goes on. But we're going to say ABK plus the measure of angle KBC equals the measure of angle ABC.
Measure of angle, that little sideways mark with that angle mark, ABK, plus the measure of angle KBC equals the measure of angle ABC.
And we did this postulate back in Chapter 1, and it was actually on your Chapter 1 test. We just didn't call it angle addition postulate. We did it, It's something that makes sense to us. You're able to do it, but we just didn't name it because we didn't have to justify. So we're going to start by drawing our angle ABC. So ABC. You can draw any angle you want. I'm going to do an obtuse angle. So we have those 3 points. Which point is the vertex?
The middle, which one is that? Name that point.
B. Good. B is that vertex. Okay, I'm going to make that angle my green angle. Okay. All right, now we know K is on the interior. What does it mean for something to be in the interior? If you're an interior designer, what are you designing? Inside, yeah. So interior is on the inside. So we're going to go on the inside of this angle somewhere. Doesn't matter where. We're going to put a point K. Put it anywhere on that inside. Now if I draw B to K there, if I'd make that a ray, that split that one angle up into, how many angles do you see now? 3. There's this one here, and then the whole angle. That was a trick question. I was expecting people to say, they're smart. Alright, so if I look at ABK, I'm going to look at this first one. Okay, so measure of angle ABK. A to B to K. So I'm looking at going from one side to the other. How much that is. And if I add that together with KBC, so then I go from here to here. So remember, we're thinking of that space. It's kind of like opening a door. If the door starts here, and I open that door to here, and then I keep opening the door to here, we're just thinking about where did we start and where did we end. So if I take these two angle measurements together, I'm really thinking, how much is that whole angle amount? From beginning to end. And that's going to be my measure of angle ABC.
Notice we're using that same color as when we marked that original ABC, so double check that you've got that same color there.
All right, we're going to jump down to the vertical angles theorem, which is not centered. It's going to drive me nuts, but it's okay. Breathe through it. Vertical angles theorem says if two angles are vertical angles, then they are congruent. Does anyone remember what is a vertical angle?
What do you remember, Anthony? Up and down?
Mm-hmm.
Yeah. Or what else?
So it happens when how many lines are crossing?
Yeah. Two lines cross.
How many angles are formed there? 4 ones. We could combine a couple and make more, but you're right, 4 main ones. So let's label them. I just like to do 1, 2, 3, and 4. So the ones that are vertical are going to be the ones that are congruent. So let's start with angle 1. Angle 1 is going to be congruent to what's the vertical angle of angle 1? 3. Good. This one on top and this one on bottom are vertical angles. They're across from each other. They share that vertex, but they're not like right next to each other. It's like how Mr. Tyson is next door to me. He wouldn't be my vertical angle. Remember, that's my adjacent. Vertical would be like across the hall. Okay, so angle 1 is congruent to angle 3.
So when we see that word vertical, we think up and down. But when we're talking about angles, there's another option as well. That would be called a vertical angle that doesn't have to be upside or up and down. So what are the other two angles that are also called vertical angles? 4 and 2. And really those are like across from each other, but they're also called vertical angles.
Good luck. Okay. That was really aggressive when I said good luck. I didn't mean it like that. Sorry, so angle 2 is going to be congruent to angle 4. Alright, and we actually noted that when we did those note cards. We said that they're always congruent. That was something we told you. At this point, we could prove that. We could take time and go through and prove how that's a linear pair, and the linear pair adds up to 180, and then these are a linear pair, and they'd add up to 180. So then these two are going to be the same because those two have to add up to 180. It turns into this whole long proof. Lucky for you, we're not doing that proof today. We're going to do a different proof. All right, next up, we have the supplement theorem. Supplement theorem is if two angles form a linear pair, then they are supplementary angles. If two angles form a linear pair, then they are supplementary angles. So there's a couple of big keywords there. We're going to start with that hypothesis, the if part. What's one of the key words in the if part, the hypothesis? It's one of the vocabulary words that we need from that. Linear pair. What does it mean when two angles are a linear pair? What's that base word of linear? Line. They make a line together. So we're going to start by just drawing a line. Doesn't matter what the line looks like. And we need that instead of just one straight line, we need an angle. So we're going to just make an angle come out somewhere in between. And this goes with the angle addition postulate, which says if I take this angle, let's call it 5, and I put it together with angle 6, together they're going to make that straight line across. And how many degrees is a straight line? 180. And when two things add up to 180, that means that they are supplementary. Okay, kind of a lot of keywords there. So we're going to write that the measure of angle 5, when I add that to the measure of angle 6, together they make a line, so they'll equal how much? 180.
Is that true that whenever we add two angles together to 180? No. Like if you look at our first one, that angle addition postulate, this one does not equal 180. So that real key part here is that if they form a linear pair, so if they make that straight line, then we can know it's 180.
Sometimes I like to color things in and then I like talk about them. Sorry, my brain was just working on that one. I don't know if that makes sense, but if it does, you can color code it like I did. So I did it similar to how we did that angle addition postulate. So I did angle 5 in that yellow, angle 6 in the pink, but then I know together they're going to make that nice green line as I go from 5 to 6. If I start at the beginning and end at the end, end at the end.
If you want to be extra fancy, you could do the word supplementary or linear in that green.
Ooh. Miss Ryder is a genius when it comes to coloring. Alright, let's go to that complement theorem. We're going to actually go to the right now. Okay, so on this one it says if two angles form a right angle, then the angles are complementary angles. So what's our key word first here? They have to form a right angle, and then when they form a right angle, they're complementary. And complementary means they have to add up to how much? 90. So we're going to start by drawing a right angle. Remember, a right angle is how many degrees? 90. How do I show that it's a right angle? Yeah, a little square on the bottom. Good. Vivian's here today. Who else is here today? Anyone else want to talk? She's doing great. She's carrying the class right now. Alright, so we have that right angle. And then we're going to just split that into two angles. So you can just draw a ray in any direction there, however it makes sense to you. Doesn't have to be directly in the middle. Somewhere on the inside it does have to be, though. Alright, so this is going to be 7 and angle 8, just because we're naming numbers. And again, this is that angle addition postulate. We know together they make this 90-degree angle. So we know that when I take measure of angle 7 and I continue to work with it in measure of angle 8, we end up with that whole right angle. So I'm going to write that out in the math part. So measure of angle 7 plus the measure of angle 8. Together they're going to equal how much? 90 degrees. And again, that's something that we've been working with. That was actually on your first test. I don't know if it was on the test. It was definitely in the first practice. It was in the 1-7 practice. Maybe? Was there 7 lessons in chapter 1? I don't remember. Anyways, we did practice this back in chapter 1, where it said, okay, if this is 30, how much does this have to be? And you guys were like, oh, it's 60, because 30 plus 60 equals 90. Something we've done, we just have to name it now, because as we use it in a proof, we have to be able to justify where did we get that from. All right. You guys ready for your mind to be blown? It's your mind being blown, I know. It's happening. All right, congruent supplements theorem. This one's nuts. It makes sense after we think about it for a really long time. You have to kind of just let it settle. You know, like when you eat like a spicy burrito and you just have to let it settle in your stomach? This is that. It's a spicy burrito. It's a lot. It'll get through. You just gotta give it some time. Alright. Angles supplementary to the same angle. Where did this or come from? Cross that or out. Are congruent. Angles supplementary to the same angle are congruent. What the heck does that mean? Good question. Alright, we're going to draw a handy-dandy angle here. Like that. That's angle 9. Because that's the number we're on. We did 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if I add it with angle 10. And angle 10, I'm going to make a small little angle. just a teeny tiny one. And I know that that equals 180 degrees. Now if I take the same angle, let's say angle 9 again, so we're going to draw the same angle. Try and get those two to look the same. Plus angle 11, so that's a different angle. But we know those two added together equal 180. What this ends up telling us is this 10 and 11 have to be the same angle.
The same measure.
Yeah, that one. Same measure, because they're congruent. They're not the same angle. Messed up, Miss Snyder. Crushed it.
You're like my cheerleader today, and I really love this.
Do you? Because that show was really hard without you. I cried. Just kidding, I didn't. Maybe I did. Anyways. Alright, Jaden, give me a degree that this obtuse angle would be. So something great bigger than 90. 160. Alright, if this is 160 degrees, 160 plus what would make 180?
So what does angle 10 have to be if we want it to be 180?
20. Okay, now if I have a different angle, I'm switching it to angle 11, but angle 9 is the same, so this is still 160. What does angle 11 have to be to make 180? 20. There's only one number that we can add to 160 to make it 180. So that tells us that that measure of, or sorry, not measure, that we know at angle 10 is congruent to angle 11. All right. Here we go with the next one. Congruent complements theorem. Congruent complements theorem says angles complementary to the same angle are congruent. It's very similar, just this time we're going to do complementary. So instead of adding up to 180, what do we want it to add up to? Okay, so it says angles complementary to the same angle are congruent. If we compare them, the only word that's different is that supplementary and complementary. And we talked about how supplementary makes 180. We also noted it up here that that was 180. What does complementary mean? Adding to 90. Vivian again for the win. Crushed it. Alright, so again, if I have an angle, this time it has to be acute. So I'm going to do angle 12. We're on 12 already. And I add that with another angle, 13, and it equals 90 degrees. These are some bad drawings of angles, people. It's doing so good for so long. And that's okay. But now if I have that same angle 12, and I add a different angle, but I get 90 degrees, but that angle is 14, because they both add to 90 degrees, we know that these two have to be the same. So angle 13 would be congruent to angle 14. We're doing great. You guys are crushing it. It's a lot of notes. Now we got to do some proofs with these notes. So we got to think about how we're going to do this to solve some problems. It's going to be great. So good. You guys got this. Naya's really excited. She looked at me and was like, yeah. Turn up. Love it. Alright. So we have two proofs we're going to do. We're going to start by doing a proof of one of these theorems. Okay, when we prove a theorem, we can't use the theorem when we prove the theorem. We're trying to show why it works. Okay, or how it works. Okay, so I'm going to tilt my paper the other way.
Now would be a fine time. We're done writing on the little sheet.
We're going to go to this side. So if you need to glue yours in, take time to glue that in quick. If you want to just keep it out, that's fine too. Alright, so for problem 1, we are going to prove the congruent supplements theorem. So we're just jumping straight into our proofs. Close the door. Alright, prove congruent supplements theorem. So to prove that theorem, we need to go back to that theorem and read it, because that's what we're going to try and do, is prove that theorem. So, angles that are supplementary to the same angle are congruent. So, for our given, we have to have angles that are supplementary to the same angle. So you have to have two different angles supplementary to the same angle. You guys ready? Got this? Alright, for a proof, we're doing a 2-column proof.
Alright, so let's think about how we set up this 2-column proof. Because I noticed yesterday on the practice work, some of us maybe panicked when it came to filling in the proof. And we kind of forgot what we would put first in those first 2 columns. So, in that very first column, what is like our name or our label that we would use? What goes at the very top? What goes on the left side? Statements. So if you want to go back and if you did not like your score from yesterday and you want to go back and do that, this would be one thing to check. Check, I think it was on like number 4, where you actually had to put the, what number was it?
Whatever the last 2 were.
Yeah. You had to actually put the label on the column, so that the first one should be statements, and then what goes on the right? Reasons. There you go.
And we know right away, before I even write my first statement, what's my first reason going to be? Given. Most people got that, but they thought that given was going to go in the first blank.
Right, so it went up
where the reasons were, but on those last 2 problems, you had to actually title the columns. Alright, so for our given, we need to have 2 angles that are supplementary to the same angle. Okay? So let's just call them angle 1 and angle 2. Is that okay with you guys? Or do you want to go with what we have on the picture? Do you want to
do 1 and 2, that way we know they're not always the same.
Okay. And what do we want angle 1 and 2? What angle should they be supplementary to? Give me a number lower than 10. Okay, so we know that angle 1 is supplementary to, and I'm going to do supple, to angle 8. But we also know that angle 2 is supplementary to angle 8.
Rather write out that word supplementary if you can. That will help you remember it.
And that's all we're given. In the end of this proof, we want to show that these angles have to be congruent. Angle 1 has to be congruent to angle 2. Okay? So for number 2, What does it mean when two angles are supplementary? What is that definition of supplementary?
Look back if you need to. They add up to 180.
So if I take the measure of angle 1 and I add it to the measure of angle 8, together they're going to have to add up to 180. So that comes from that angle 1 is supplementary to angle 8. We have another two angles, though, that are supplementary. We know that the measure of angle 2 plus the measure of angle 8 equals 180. In this problem, we used a word to help us. So when you usually use like a word, that's usually a definition. So this is going to be our definition of what word told us 180. Supplementary, yep. So this is our definition of supplementary. Alright, remember we're trying to prove that angle 1 is congruent to angle 2. So I want to show that these are the same. So for step number 3, I want to write a sentence or a math equation that includes both 1 and 2. So I'm going to start by writing that first equation, measure of angle 1 plus the measure of angle 8. Instead of writing equals 180, though, what can I replace that 180 with? What else equals 180? Yeah, 2 plus 8. Nice job, John Deere. Measure of angle 2 plus the measure of angle 8. Because they both equal 180, so if they both equal 180, they equal each other. What do we call that when you switch something out for its equal part? So instead of writing 180, we switched out that 180 for something it was equal to. Substitution. This one's a little goofy. It could be substitution, or this one could be transitive. Not technically transitive, but if you wrote transitive, I would have accepted it as, yep, that works. Those two can be kind of hard to tell between the two. All right, now our goal is just to get angle 1 and angle 2. So what do I need to get rid of on this side to get just angle 1? I need to get rid of which part? The 8. How do I get rid of adding a measure of angle 8? Subtracting. So I'm going to do minus measure of angle 8. And if we do it on one side, we have to do it on the other side. So what's my property going to be when I write this next statement for number 4? What did we do? Subtraction. Good. All right, so I'm taking away that measure of angle 8. It's no longer there. So what am I left with on the left side? Measure of angle 1 equals measure of angle 2. Yeah, you had it. So they're equal. We talked about it this morning. What does it mean when they're equal? They're congruent. Angle 1 is congruent to angle 2. What is that when I say that if they're equal, that really means they're congruent? definition of we're going to start with that word congruent, right? And are we dealing with segments or angles? Angles. If you wanted to put the symbol in for congruent, you can. I just wanted to write it because, I don't know. Just being fancy. You know. Alright, we have one more that's really short compared to that one. So we're going to draw a line across. I'm going to draw a line across because these just kind of mush together in my brain sometimes. Alright, number first. Alright, so for number 2, I'm going to have a straight line and another straight line. Okay. And then over here, I'm going to just do this other angle over here.
Take a moment, draw that in.
Alright, we're going to label some of these angles. I'm going to label this one as 1, 2, 3, and 4. And then over here is going to be angle, you want 5? Or do you guys want a different number? 5? Stick with the 5? Okay. We're going to be given that angle 5 is congruent to angle 3. And we're going to try and prove that angle 5, the measure of angle 5, no, sorry, just angle 5, is congruent to angle 1. Sorry, trying to base on how much time we have left of class of how complicated I can make that one.
All right, pause, take a moment, kind of read through that in your brain. Look at the pictures. Picture what that is actually talking about. We know that 5 and 3 are congruent. And we're trying to prove that angle 5 is congruent to angle 1.
And I'm going to tell you right off the bat, this one is 3 steps. It's a shorter one. So, let's fill in what we know based on it being 3 steps. Alright, so how are we going to set up our proof? What are some things that you could do without my help? Write the given. Before we write the given.
We've got those 2 columns. Reasons, where does that go? This side. And then what goes on that other side? Statement.
Alright, once we write that, then what are we going to do, Vivian? Write the given. Do you want to write the word given, or you mean like we're going to write the statement for given? Both. Alright, do you guys want to use letters or numbers? You guys like numbers? Okay. So for number 1, our first statement is going to be the given. What is our given? Angle 5 is congruent to angle 3. Now, I told you this was going to be how many steps? Does anyone remember? I just verbally said it. 3. So I'm going to do 1, 2, 3.
Is there anything else we could fill in right away then? The proof. So that's step 3. We don't know the reason quite yet, but we could fill in what we're trying to get to.
So we know that we're trying to get to angle 5 is congruent to angle 1.
So this is a really good strategy for when you are doing this on your practice work or even on your tests. If you look at something and you kind of panic and think, I don't even know where to start here. If nothing else, it's going to get you some of the points. But also, sometimes that can help you sort of separate into little steps and not get so overwhelmed with how many different things you have to do. Now we're just going to try to go step by step.
All right, so I'm trying to connect 5 with 1. And right now I know that 5 is congruent with 3. How can I get 1 involved in that mix?
So just from looking at that image, what do we know about angle 1? It's congruent to what? We don't know that yet. We want to prove it. What do we know from the image? It's congruent to 3? Why? What's John Gill trying to tell us? What's that called when they're across from each other? Vertical.
Vertical, good. So we know angle 3 is congruent to angle 1. Because what type of angles are they? Vertical angles. So this is the vertical angle theorem.
We're just shortening that up. Angle theorem.
So now if I know this is the same as this and that's the same as that, I really know they're all the same. So can I pair 5 with 1? Yeah. Remember, this is where we can write it out in that kind of that train. Angle 5 is congruent to angle 3. Angle 3 is congruent to angle 1. So I can really start at 5, and that train allows me to travel from angle 5 to angle 1.
You might have to look back for this one. So what tells us we can go from 5 to 1? You know it? Transitive, nice.
And is this the transitive property of equality or transitive property of congruence? How did you know congruence? Yeah, it's a congruent sign. Okay, so when I think of this, I think of that word travel, like you travel from first to last. If you want to make a note of that, some people I know had a tough time yesterday remembering when we use that transitive.
For me, that